All right, so we got that one. Let's compute investment B. So remember, the formula is different. So how do you fill this one in? Good call on the 0.0685. A lot of kids, and myself included in years past, put 0.07 there because you forget that it's a different interest rate. So let's see if you got what I get. First thing I would do is I would do 0.0685 times 6. Then I raise e to that power, and I multiply by 8,000. That number look familiar? All right. So this would be $12,066.60. So clearly the investment with the higher interest rate, even though it's compounded a lot less often, is worth more money in this case. Now obviously if there was a less of a discrepancy between the interest rates, then this continuous one might overtake it. Okay? Now, out of curiosity, I wonder what would happen if we did 7% compounded continuously. Because that would be the maximum amount that you could get, because you couldn't compound any more often than that. That would be the maximum amount at 7% interest. Does that make sense what I'm trying to say? So, just for the heck of it, let's compute that. So, we'd have 8,000, this would be e to the 0.07 times 6. 0.07 times 6 is 0.42. So 0.42 raise e to that power times 8,000 gives you $12,175 and change. Now, how much did we get when we compounded monthly at 7%? Wasn't it like 12,160 or something like that? So basically the difference between compounding monthly and compounding continuously on an investment of $8,000 over 6 years is 15 bucks. So they're really not cheating you out of too much money just doing it monthly and not continuously. It's not that big of a difference. And that is 4.1.